Hello, welcome to this video on translations. So in this video, we're going to be looking at these two skills. We're going to be looking at how to translate a shape by a given vector and how to describe a translation that has taken place. So we've got this little picture here to illustrate what a translation is. So a translation is where a shape moves up, down, or from side to side, but it does not change its appearance in any other way. So we can see from this picture here, the purple shape has moved 3 down and 4 to the right, and it's now become that green shape. So every point in the shape is translated when you do this, and it's always the same distance in the same direction. So every single point has been moved 3 down and 4 to the right. So in terms of describing translations, we use column vectors to describe these. So I'll give you an example. So 4 minus 3 means 4 squares to the right and 3 squares down. So this top number here, that number 4, so that number 4 there, that will always describe whether you are going left or whether you are going right. So if it's a positive number, you're going right. If it's a negative number, you're going left. And this bottom number here, this minus 3, if it's a negative number, you're going down. If it's a positive number, you are going up. So another example here, we've got minus 2, 1. So that means 2 squares to the left and 1 square up. Okay, so we've got an example here then. So it says translate triangle A by the vector 5 minus 3. So what that means is we're going 5 to the right and 3 down. So if we take this point here, we'll start from there. So we're going 1, 2, 3, 4, 5 to the right, and then we're going 3 down. So 1, 2, 3 down. So the new shape is therefore going to start down here. And this side here with 3 squares, so it was nice 3 vertical squares there, so we can draw that just there. And then we've got 2 squares going like that, and then we can join it up like that just there. If you want to, you can do it for each individual vertex if you want to, each individual corner. So we've got here 1, 2, 3, 4, 5, and then 1, 2, 3 down for that bottom one. If you wanted to check you've done it correctly. Okay, let's take a little look at this one then. So on this one here, it's asking us to go 3 to the left this time because it's a negative number, and we are going 1 down here. So if we just take maybe this point on your rhombus here, so we are going 1, 2, 3 to the left, and then we are going 1 down. So our new shape is going to start just here. Let's try it with that bottom one as well, just to make sure. So on the bottom, we're going 1, 2, 3 left, and then 1 down. And then we can just draw in every point there. Just join it up with your ruler. And there we go. We have our completed rhombus. Okay, so now we're going to take a look at how you go about describing a translation. Okay, so this one here then, we are now being asked to describe the single transformation. So obviously this video is about translation, so you know it's a translation, but you would not know this in an exam. So the way to identify a translation is it's exactly the same shape. It looks exactly the same. It's just in a different position on the grid. And we're being asked to translate, describe A to B. So we would write translate by the vector. Then we need to work out our vector. So if we just take this point on the shape, it is going to be 1, 2, 3, 4, 5, right? So we're going to have a positive number on the top of our vector, and then we are going 1 down. So it's going to be -1 on the bottom of your vector. Okay, our final question then, another description one. So again, we need to write the word translate. It's always important to write down the type of transformation you're working with. And then for any translation, we need to write down translate by the vector. And if we look at the vector then, let's start with this point here. Well, we're not moving left or right, so it's just going to be a 0 for our top number. And then we are going 1, 2, 3, 4 squares down. So it's going to be -4 for the bottom number on our vector.